In grade 12, we focus not only on the functions that we've been doing up until now, so our straight line, our parabola, hyperbola, and our exponential graph, but we're also going to look at their inverses, and that is the new part. So when you are going to be tested, you will be tested on both those four main algebraic functions, as well as the inverses of them. The first important part is you need to know what is a function. Okay, because not all of the graphs that we are doing are functions. So this is now a lot of words. This is what the fancy thing that it says in your textbook. So it says a function is a rule. Okay, so you need to know it's a rule or formula that is linking two variables, your x and your y. It takes an input, a x value, and produces an output by applying a certain procedure, whatever. That's your rule part. Then you need to know for that rule or that formula to be a function, it can only produce one output for every input. Only one y for every unique x. Okay. There can be two different x values that have the same y. That's fine. But one x value can only have one y value. So this is more condensed definition. A function is a relation for which every x value in your domain, okay, you need to know domain is x values, for every x value in your domain is associated with only one y value in your range. Then let's quickly look at inverse functions. An inverse function is a rule that has the opposite procedure. So, like for example, right back in grade 8 when you started with algebra, you would have said maybe if you have y equal to 2x plus 5, and you had to, maybe they gave you a y value or whatever, and you don't need to solve for x. Then you would have had gone and look at what is happening here to this x. You are timesing with 2, and then you are adding 5. So the inverse procedure of that would have been you first subtract 5, and then you divide by 2. So that is what an inverse function is. You are going to have to do that for every single one of the functions that we work with, those four main ones. And you will need to be able to find, given the formula, the inverse of that. And the easiest way, or the main way how we do it, is we are going to, well, this, I wouldn't really call this part a step, but you can say it's a step. If your function is given as f of x equal to 2x plus 5, then you need to just make sure that's a y, okay? Or you need to know if x is the same as a y. So I wouldn't really call that a step. Then you are going to change your x and your y. So you're going to, where there was a y, you replace it with an x, and where there was an x, you replace it with a y. Okay, so the other part, that stays, but your x and y swap. So here was a y, so it becomes an x, and there was an x, so it becomes a y. And then you're going to make y the subject. And you are going to do that by first subtracting your 5. So you'll have x minus 5 is equal to 2y. And then you're going to divide by 2. So that you have x minus 5 over 2 is y. And you can also write this as, so if this one was f of x, we use the symbol -1. Okay, so this is called the inverse function of f. If this is f of x, then this is the inverse of f of x. That's how you read that. Is equal to, and either you can leave it like this, or you can go and just divide each of the terms by your 2. So x over 2 minus 5 over 2, which you can also write as a half x minus 5 over 2. Okay, so that's the important thing of an inverse function. So do you see how this actually relates to what we said here in the beginning, where it's the inverse procedure or the opposite procedure, where usually what would happen to this x to get a y is you would multiply with 2 and then you would plus 5. So we are now doing the opposite. We are first minusing the 5, right? The opposite of plus 5, and then we're dividing by 2, the opposite of times 2. Oh yeah, and then the other important part is an inverse function is the reflection of the original function around or about the line y equal to x. We also looked at this a little bit in grade 9, or we were supposed to. I think the current grade 12s had still COVID grade 9, so it was a bit iffy if we did it, or if you did it or not. I wasn't there. But definitely from 2026's grade 12 should know about reflections, and when we did transformations in grade 9, and then yeah, we know when we reflect about the line y equal to x, we swap the x and the y, which is what we did here. We swap the x and the y. Then there are two tests that we use for whether something is a function or not, and then classifying that function. So firstly, the vertical line test tells you yay or nay, is it a function? So for example, if we have a normal parabola, okay, like we've been used to, if you take a ruler or a straight edge, I think that's what they call the ruler without like the indications on it, like the lines. But anyway, if you take any like somewhat straight thing, whatever, and you put them vertically, okay, and everywhere it only cuts once. Do you see? It only cuts the graph there one time. Here it cuts the graph one time. And if you can do that everywhere, remember, it's difficult when you're actually drawing a parabola because we are not computers and we're not perfect. But those arms continue going wider and wider and wider. The amount by which they grow becomes a little bit less, a little bit less, a little bit less. So it's the change is more obvious there around the turning point, but the graphs do continue growing and growing and growing further apart. The arms do continue growing further and further and further apart. So you will not be able to draw a vertical line where it cuts the graph twice. But I'm going to get to this in a very, very soon. This is the inverse of a parabola. Okay, we'll get to that. But here, do you see, if you draw this line like they did here, it cuts the graph two times, then it's not a function. Yeah, so if it cuts one time, function. Cuts two or more times, not a function. That's what you need to know. So another example of something that we know is not a function would be a circle, okay? Because like if you look just at the axis, that's a vertical line. Do you see it cuts two times? So okay, not a function. Horizontal line test determines if a function is one-to-one or many-to-one. Okay, so basically how the one-to-one, many-to-one thingy works. These are our main four algebraic functions that we do. Okay, we will, when we do the straight line video, it's going to be a concolonicable. I don't know what that is in English. Like, it's going to be a part. But anyway, for straight line, a normal, like a increasing or decreasing straight line. If you make any horizontal line, you'll see it only cuts once. So it's 1. Those are the x. Horizontal is 1. And any vertical line cuts also one time. So this one is a one-to-one function because it is a function. Okay, all of these are functions. Then we'd first do horizontal line test. This, except obviously they're by the turning point, any horizontal line you drew will cut two times. Okay, so you'll say this is many. You don't say 2-to-1, you say many. 2, and then y, okay, any y value will cut one time. So it's many-to-1. Similarly for the other ones, if you draw horizontal line, it only cuts one times. And for this one also, any horizontal line will cut one time. And any vertical line will also only cut one time. Similarly here, cuts one time. Okay, obviously this is for within its range and within its domain, right? Because if you go draw a line there, then it's not cutting the graph at all. But that doesn't make it now a none-to-one or whatever. Okay, so please keep that in mind. It's for within the range or within the domain of this graph. Okay, where it exists. Okay, so we don't define it by where it does not exist, basically. Okay, so just to sum it up, horizontal line test you use to get the first part. So you first do horizontal, then vertical when you are describing the graph. So it is one-to-one because it's horizontal, then vertical. Horizontally, it cuts more than one time, so it's many to vertically, it cuts once, and so forth. Okay, so for the main container, the main guys that we did in our functions for paper 1, the only exception that we're going to talk about right now, we're going to get to the one with straight lines in a moment, but like generally, the exception for being one-to-one is a parabola, and then there's going to be a story there by straight line. But stay tuned for that. Also, just a note, you can also describe something that's not a function in this way. Like if we look at both the circle and the inverse of the parabola, if you draw a vertical line, which is y value, y, okay, vertical is y, how many times it cuts the y values, you see it's 2 times. So that would make it a many, right? Which makes it not a function. Similarly, with the second one, it cuts more than once. So those are not functions, but you can describe them also using this way, if they ask for that. And you see horizontally, this one cuts more than once, so it's many to many. And this one only cuts once, okay? Any place, it will only cut once. So this will be one to many. But remember, this green part every time tells you whether it's a function or not. Vertical tells you whether it's a function or not. Horizontal is used to describe it a little bit more.